Hello, it's Keith here. This is lesson 13 of the YQuest series. We're back to the Master System again, bit of a surprise, and I've got a new version of the game. This is kind of YQuest2 if you would call it that, because now look at that nice smooth movement. We're using hardware sprites. If you don't remember, the previous version of this game just used the Tilemap, so the movements were very jerky. Everything was moving in 8x8 sort of blocks, and that wasn't very nice. But we've made a few tweaks to the code, and now we've got hardware sprites working, so we've got that nice smooth movement back. We're going to be having a look at the code that's done this. It hasn't actually taken very much work to get this working, so we're going to have a look at what's changed now today. Let's go over to the code and have a look. Okay, so here's the code. This is the YQuest platform specific code, and here's the multi-platform code. Now first we're going to discuss what's changed in the multi-platform code. Now one first thing that has changed is there was originally one spare byte of the object definitions that was completely unused. It is now being used. It's now a hardware sprite number. Now this is quite handy because what I've actually done is I've actually said that the code will check this hardware sprite number. If the number is 0 or 255, it will ignore the object and continue drawing it with the Tilemap code. But if it's any other number, it will use that hardware sprite number within the system, and that's platform specific of course, and it will use that to draw that particular object. And that means we can have some game objects that are drawn with the Tilemap and some game objects that are drawn with hardware sprites, and that's very handy for systems with limited number of hardware sprites. You know, if you've only got one hardware sprite, move the player with it and do everything else with the Tilemap. If you've got 10, then you maybe do the player and the player's bullets. If you've got 128, then do everything. So that's what we've done, and it's allowed us to easily shift from a Tilemap based system to a hardware sprite based system without too much work. So that new code is being used there, and that is being processed in the code here. Now the first consideration is we're going to need to define which hardware sprite is being used by which object. So we've got this set hardware sprite command here, and that will set consecutive objects within an object array with hardware sprite numbers, and C is the sprite number, B is the count, and IX is the first of the objects to set, and it's going sequentially, and when it returns it will have the consecutive sprite number again, and you will see that later on. So that's where we are actually defining our sprites. Now the code that's actually doing the drawing of the sprites is going to be primarily in the movement routine, and here it is. Now you can see here we've got the code at the end of the movement routine, and this is going to handle the drawing of an object. Now do get sprite object is our old Tilemap routines on these systems. Do get H sprite object is the new hardware sprite routine. Now this will handle the hardware sprites for the platform specific code. So what we're checking here is we're checking to see if the sprite is using sprite number 0 or a sprite number greater than 128, and if that's the case we're assuming it to not be a hardware sprite. Effectively 255 is our uninitialized bullets and 0 is the default for the data, so I'm assuming either of those is going to be a non-hardware sprite, and a number between 1 and 128 is going to be a hardware sprite, and we're going to use that do get H sprite object routine to draw those hardware sprites. Okay, now the hardware sprite routine code is of course within our platform specific routine, because hardware sprites are very platform specific. Here's the code. So this is basically very similar to our old get sprite object code. This here, it's just been tweaked slightly. Again, we're just calculating the sprite frame here to select the pattern that we're going to use. Now on the Sega Master System and the GameGear, they're actually using the same patterns, so all we're doing here is we're calculating the tile number here. Again, we're just adding 96 because our first 96 is the font, and then we are calculating the X and Y position. Now this time of course the X and Y position are very high resolution, so whereas before we were having to remove all of the resolution definition here, we're now actually having to increase it, ironically, because the X location is actually too low resolution, so we're multiplying that up there, and we're going to then use this get set hardware sprite routine just here, and this is going to transfer the XY position and the sprite pattern data to the sprite number. And so to do that we need to define the 3 bytes in the Master System VRAM that define the sprite definition. There are 3 bytes in total. The first byte is at 3F onwards, and that is the Y position, so we're calculating the memory offset 3F00 plus the hardware sprite number here, and then we're setting the Y position in there with those commands. Then the next 2 bytes are at 3F80 onwards, and that's the X position and then the tile number. So we're multiplying the hardware sprite number by 2, adding that to 3F8T and selecting that VRAM address, and then we're writing the X position and the tile number here, and that will set one of the hardware sprites as visible on the screen. The final thing we need to do is we need to clear the sprites off the screen. So when it comes to clearing the screen and we need to remove those sprites, you can see the code here, and all we've done here is we've added an extra piece of code here, and we're just setting all of the hardware sprites to be off the screen and to be tile 0, and that will remove them effectively from the screen. So that's how we get our sprites to the screen. The last thing to do is to define which object is going to use which hardware sprite, because we can't use hardware sprite 1 for two objects that are both simultaneously on the screen. So what we're doing here is we're defining that with that set hardware sprite function we saw before, and that will consecutively set an object array pointed to by X, a count pointed to by B, and a sprite number pointed to by C. So first here we're defining the hardware sprite number for the player object, and then we're defining the hardware sprite numbers as being consecutive sprites from there onwards, and we're doing that with this set hardware sprites function just here, and that will consecutively set the other sprites of the bullets, the enemy bullets and the objects to be consecutive hardware sprites within the system here. And so that's all there is to it. So there we go. So that's what we need to do to get the hardware sprites working, and I think the result has been fairly effective. You can see here we've now got our nice smooth movement on this system, and it's not taken a whole lot of code to do it. So I think that's quite satisfactory. Now we're going to be doing this on a variety of other systems, adding hardware sprites like this, and so hopefully YQuest will be a lot better on the tile sprite based systems. So there we go. Anyway, as before, you can go to my website and you can download the source code for YQuest in all of its iterations, including these new hardware sprite versions, and maybe it'll be useful to you if you're making your own little games. I hope you've enjoyed this. If you have, please like and subscribe. Thanks for watching today, and goodbye.